In this video, we're going to do some examples where we're given some graphs of lines and we need to write their equation in slope-intercept form. So there's a bunch of graphs here. I'm going to pick a few of these to work out, and then the rest of these I'll give you more time to work on in class. So for this first one, I actually see two lines, a vertical and a horizontal. So let's focus in on the horizontal one. So to write the slope-intercept equation, I need to know the slope. So m, my slope. Well, if I take any 2 points on that horizontal line, well, the rise is 0. So the rise is going to be 0 divided by whatever the run is. I'll just put a squiggly line because 0 divided by something else, that's just 0. And then comma b, the y-intercept, well, that's crossing at 2. So then if I write my slope-intercept equation, y equals mx plus b, well, if I plug in 0 for m, I'll get 0 times x, which is just 0. And then I'll plug in 2 for the b. So this just becomes y equals 2. Y equals 2, and that's the equation of this horizontal line. The vertical one I want to leave for you to try. Okay. All right, so next let's jump to part D here. So again, I need to know the slope. So the slope and the y-intercept. So let's focus on 2 points that I know the coordinates of. So we know the coordinates of this point and of this point. And I see that the rise I'm going down 2, and then the run I'm going over 3. So I get -2 for the rise, and then 3 for the run, comma, and then my y-intercept, b, well, that's down here at -2. So -2, and if I plug that in to y equals mx plus b, I get y equals -2 over 3, right? Because if I have a negative on top of the fraction, I'm allowed to just move it in front, and then times x, and then I'll get plus this -2. That's the same thing as just writing -2. And there we got the equation. Okay, so let's do one more here. So let's try this one, part F. So again, I'm going to need to know the slope, m, and then the y-intercept, b. One thing that makes this problem different is the scale is different. I see that this tick mark is at 100, and same thing for this one. And I notice it takes 1, 2, 3, 4, 5 of these tick marks to get to 100. So 100 divided by 5, that's 20. So this first tick mark is at 20. Okay, that means the next one would be at 40, and so on. Similarly, in the y direction, there's 1, 2, 3, 4, 5 tick marks before I get to 100. So this would be 100 divided by 5, which is 20, and so on. So let's focus in on 2 points that we know. So I know this point, and I know this point to get the slope. So for the slope, my rise, well, I go up, let's see, I go up 1, 2, 3, 4, 5 of these tick marks. So 5 times 20 is 100. So my rise is 100. And then over my run, I go over 2 tick marks. So 2 times 20, that's 40. So 40 for the run. And I could simplify that. I can divide the top and the bottom by 20, and that gives me 5 over 2. So the slope is 5 halves. And then what's my y-intercept? Well, it's down 1, 2, 3, 4 tick marks. So 4 times 20, that would be 80. But since it's in the negative direction, it's -80. And then from there, I can write my equation. I'd get y equals 5 halves for the slope times x, and then the b value -80, and there we got the equation. So when I can quickly figure out the slope, and I know the y-intercept, if I can see that on the graph, then writing slope-intercept form for the equation is very quick. But if I'm not given the y-intercept, if I'm given instead some other point on the graph, and I can find the slope, usually it's going to be quicker to write down the point-slope form. Okay, so the rest of these practice problems will have more time to try these in class.